Hi, let's look at this coordinate geometry question. So we are given that the equation of this graph is y is equals to 4 minus x plus 2 squared. Alright, so the first thing we want to know is how can we relate this equation to this graph here. Now, in order for us to map or translate a quadratic equation into its graph, you can do it in different ways depending on how the expression is already given. All right. Now, when you look at this expression, we can say that this is an expression where the quadratic equation has already been factorized by completing the square. All right. So when we complete the square, okay, what we have is, okay, so let's do a quick revision on that. When we complete the square and we have an expression, the expression can be in this form: y equals to plus minus x minus p square plus q. Now, how do we relate this to a graph? When it is positive, all right, when this coefficient here, when it is positive, it means that the graph is going to be upwards. And when it is negative, so this is for the positive coefficient, and when it's negative, okay, it's going to be this way. All right, so I'm just showing you the shape only in this uh, example here. Where it cuts the y-axis and x-axis depends on other parameters. Now, another important thing we can also get from this expression is p and q. Okay, p and q together actually tell us the turning point. Okay, the turning point of the curve. And at the same time, we can also deduce that x equals to p is the line of symmetry. Okay, so if I were to look at these two graphs here, the line of symmetry is here. Okay, and the turning point is this point here. It's either the minimum point or the maximum point, depending on how the shape of your curve looks like. So that is basically the information, okay, that you can derive, okay, when you have a quadratic expression already given in the form as what we have over here. Now, let's come back to our question here. So in the question, we are asked to first find the coordinates of the maximum point P. Okay, and the maximum point P is equivalent to the turning point. Is equivalent to the turning point. As what I mentioned just now, this expression, when we have the equation in this expression, we can straight away get the turning point as P and Q. Now let's look at the given expression. What we are given is this: y equals to 4 minus, okay, y equals to 4 minus x plus 2 squared. Now let's just rewrite it to make it look like what we have here. So we have y equals to negative x plus 2 square plus 4. Okay, now is it comparable right now? Not exactly, because as you can see here, within the bracket I need to make sure that it is a negative sign, whereas here I have a positive sign. So what I need to do, I just need to rewrite it as x minus 2 square plus 4. Now I can compare it with this expression directly, and we can now say that this is P, all right, which is minus 2, and Q is plus 4. So the turning point PQ is equals to minus 2, 4. Okay, so the coordinates of the maximum point here, which is the turning point, is minus 2. So this point here, okay, this point here is minus 2 and 4. Okay, so let me draw it here. So this is minus 2 and this is 4. Now, the next question, state the coordinates of the point Q where the graph cuts the x-axis. Okay, where the graph cuts the x-axis. Now, in order for us to do that, that means we are actually asked to find this point here and this point. So the point where the graph touches the x-axis is actually the point when the y value is 0. Okay, so all I need to do is to make sure that the expression 4 minus x plus 2 square is equals to 0. Alright, so if I bring the x plus 2 square over, so I get x plus 2 square equals to 4. So x plus 2 is equals to square root of 4, which is plus minus 2. Alright, so that will give me x equals to minus 2 plus minus 2. And the two possible values will be 0 and minus 4. So in this case, the two values here, okay, the coordinates are when x is equals to 0 and x is equals to minus 4. And as we saw just now, the point where it touches the x-axis, the y value is also 0. Okay, so these are the 2 points where the graph touches the x-axis. So the coordinate q is negative 4, 0. For C, state the line of symmetry of the graph. The line of symmetry, as we saw just now, is actually x equals to p. So the line of symmetry is when x is equals to minus 2. Okay, so actually you can see it here from the graph. This point is the line of symmetry. Alright, so if I were to draw a line here and fold the curve, okay, across, it will be a perfect fold. Okay, so that is the line of symmetry. Now let's look at the last part here. State the largest value of alpha such that 4 minus x plus 2 square equals alpha has real solutions. Okay, so let's look at this. So what I want is to say that 4 minus x plus 2 square equals to alpha has real solutions. Now let's look at what do we mean by real solutions. Okay, so alpha can be any value right now. Now let's just proceed on to solve this. So I will have minus x plus 2 square equals to alpha minus 4. Correct? Now effectively later the negative sign will come over. Alright, and when the negative sign comes over, I will then do a square root. Correct? So I will get this expression x plus 2 square equals to negative of alpha minus 4. And as what we did over here, you can see that the next step would be to do a square root. So x plus 2 equals to square root of negative alpha minus 4. Okay, now in order for me to actually be able to solve this, the square root can only be applied to a positive number. Okay, I mean there is the concept of imaginary numbers. Okay, that you will learn when you are dealing with complex numbers and so on. But for now, we can say that in complex numbers, basically there are real parts and imaginary parts. Okay, imaginary parts are the case where, imaginary parts refers to the case where you are going to do a square root of a negative number. Okay, but we are not dealing with that now. We're only dealing with the real part. Okay, so a real solution means you are actually able to do a square root of a number which is positive. Okay, now in this case, when I'm going to do a square root of a positive number, it means that this term here must be positive. Okay, so negative alpha minus 4 must be greater than equals to 0. Okay, must be greater than equals to 0. Now, in that case, alpha minus 4 must be, since the negative sign, when I multiply by negative sign, the inequality will change, less than equals to 0. So alpha must be less than equals to 4. Okay, so you can see that when alpha is less than equals to 4, okay, we can try some numbers and just let me show it to you. If alpha is equals to 2, okay, so let's say alpha is equals to 2. All right, and if I put this inside here, into this part here, minus x plus 2 square equals to 2 minus 4. So minus x plus 2 square equals to minus 2. X plus 2 square is equals to 2, and I can proceed on to do the square root. But if let's say I were to give you that alpha is equals to 5, then what would happen? Minus x plus 2 square is equals to 5 minus 4. So minus x plus 2 square is equals to 1, and x plus 2 square is equals to negative 1. And then you are stuck, because if you try to do a square root of negative 1, you can't do it. Okay, because that will lead you to a imaginary number. Okay, so for in maths there are real numbers and imaginary numbers which combine together to make a complex number. Okay, but that is beyond the scope of this topic. So for real solutions, we just need to make sure that we are able to square root a positive number. And in order to make sure that I'm able to fulfill that requirement, the value of alpha must be such that it is less than or equals to 4. Okay, so I hope that this explanation and this video has given you a good insight on how to solve this coordinate geometry question here. Alright, thank you very much for watching, and I will see you soon in the next video. Thank you. Bye.